Hello, great nurses. Welcome to the Career Pathway channel, where we guide nurses on their pathway to success. Here is your career coach. This is NUS 111 Applied Chemistry. In Module 1, we talked about how chemistry relates to nursing. In Module 2, we understood the nature of matter. And here in Module 3, we want to discuss acid, bases, and salts and their characteristics. And of course, how they relate to the nursing practice. Specific objectives for Module 3 are as follows. Number 1, acids, bases, and salts. We'll discuss the properties and uses of acid, bases, and salts. Number 3, we'll discuss the types of salts and their uses. Number 4, we'll discuss efflorescence and deliquescence. Number 5, we'll look at the examples and properties of metals and non-metals. Number 6, we'll look at the hydrolysis of salt. Number 7, we'll look at titration of acid and base. Number 8, we'll look at simple volumetric analysis. As we all know, the circles to success remain the same. Red circles indicate that these areas are a must-know for your next examination. Orange circles identify that these areas are good for your clinicals. And green circles ask you to repeat the video at recent times. Let's move to objective number 1. Objective number 1 says to define acid, base, and salt. Acid, base, and salt will look at their nursing definition, which by looking at the property, the nursing use, and then the danger zones that we should watch out for as nurses. One of the good things you will enjoy in these videos is that it helps you to apply everything you will be taught to the nursing practice. So basically, we want to define acid based on nursing definition. An acid is a hydrogen donor. Example, hydrochloric acid, hydrogen tetraoxosulfate 6 acid. Okay, the danger zones are this. It is related to stomach acid, HCl. Too much of HCl will lead to ulcer. Too little of HCl in the stomach will lead to malnutrition. The nursing action that we should take: check pH for nasogastric tube. Aspirate before feeding. The next property is base. A base is defined as hydrogen ion acceptor. Example, sodium hydroxide and ammonia. They are all base. How does it relate to nursing? Blood. Blood is buffered by hydrogen carbonate. Base deficit will lead to acidosis, which will lead to coma. The nursing action: ensure to monitor arterial blood gases in DKA patients. DKA patients are patients with diabetic ketoacidosis, okay, with diabetic patients. The next property we'll discuss is salt. Salts are ionic compound from acid plus base reaction. Danger zone. There is danger zone with regards to IV saline sodium chloride. Any wrong concentration of sodium chloride or IV normal saline will lead to hemolysis. Nursing action: we must verify that the normal saline we are giving is 0.9% on the bag before hanging it up for the patient. Properties of acid, base, and salt. We'll begin by looking at the properties of an acid. So we'll take note of this: the property, nursing use, and danger zone. Acids have sour tastes. This is critical to nursing in the sense that citric acid in urine acidifiers help to treat urinary tract infections. Danger zone for nurses. We must note that acid must not be tasted. You don't taste them. Gastric acids have a pH of 1.5. This could melt a metal. Imagine it on your tongue or on your skin. Okay? Acid also turns blue litmus to red. Nursing use: pH strips for wound care. Acidic wounds heal faster. So we use pH strip to test for acid in wounds to ensure that acids are present to make them heal faster. Danger zone for nurses. Acid can spill on the skin. This could cause chemical burn. Ensure to irrigate with water for at least 20 minutes. When an acid touches the skin, ensure to irrigate with water on a running tap for 20 minutes. Acid also reacts with metals. Nursing use: Hydrogen peroxide helps to clean wounds. Danger zone. Do not mix with iodine. This is an explosive reaction. Properties of base. As usual, we'll look at the properties, we'll look at the nursing use and the danger alerts or zone for nurses. Base has bitter taste. Nursing use. It is used in antacid. Example is magnesium hydroxide for heartburn treatment. The danger zone. Do not taste. Sodium hydroxide, which is a drain cleaner, can dissolve tissues, leading to blindness. So do not taste. Base also turn red litmus papers to blue. Nursing use. They are used in blood pH testing. Alkaline indication for pH is greater than 7.45. The danger zones for nurses. Alkaline can spill on skins. Saponification, okay? This could turn the skin into soap. So it is important to irrigate immediately. Slippery feel. Base has slippery feel. Nursing use. Sodium bicarbonate IV is used in treating acidosis. An undiluted sodium hydrogen tricarbonate IV is fatal. It could lead to embolism. Forms carbon dioxide bubbles in the line. Properties of salt. One of the properties of salt is that it is used in electrolyte solution. Nursing use. Nurses use potassium chloride for hypokalemia. Potassium chloride is used to treat hypokalemia. Critical alert. IV potassium chloride must be diluted. An undiluted potassium chloride can lead to cardiac arrest. Second property of salt is that they conduct electricity. Example, your ECG electrodes. Your ECG electrodes use sodium chloride gel. What happens is that this sodium chloride helps them to really function properly. Okay, critical alert. Calcium chloride versus calcium gluconate. Calcium chloride and calcium gluconate are actually used to treat hypocalcemia. Okay, why calcium chloride is very active, calcium gluconate is less active. So calcium chloride can damage the vein. It is advisable to use a central line only when administering calcium chloride. This is because a central line will have a lot of blood that can absorb the solution. However, calcium gluconate can be used for the same reason, but calcium chloride is highly effective than calcium gluconate. Objective number 3. We want to look at the types of salt and their nursing uses. Number 1 is normal salt. A normal salt is a salt formed by simple neutralization solution. Example, acid reacting with base to give salt and water. Example is sodium chloride. This is a simple neutralization, complete neutralization reaction forming a normal salt, which is sodium chloride. How does this apply to nurses? Nurses use normal saline, which is normal salt, 0.9 sodium chloride IV, which is isotonic fluid for dehydration. If a patient is dehydrated, sodium chloride IV fluid is usually given. The next type of salt is acid salt. Acid salt is formed from the incomplete neutralization of acid and base reaction. For example, an acid salt is sodium hydrogen tetraoxosulfate 6 acid. How is it relevant to nurses? Nurses use the acid salt called sodium bicarbonate to treat metabolic acidosis. So metabolic acidosis is caused when the base level in the body is very reduced, leading to increased acidic level of the body. The next one is basic salt. Basic salt is formed from a combination of weak acid and a strong base. Example is your calcium hydroxide. Okay. Nursing application. Basic salt is used as a form of calcium carbonate, that is an antacid for gastroesophageal reflux diseases. Double salt. A double salt is formed when two salts crystallize together. Example is potassium aluminate salt. In nursing application, double salt is applied in the use of alum. Alum stops bleeding from minor cuts. Objective number 4. We want to discuss efflorescent versus deliquescent and how they impact nurses. Efflorescent versus deliquescent and nursing impact. Efflorescent. Efflorescent is loss of water to air, which turns to powder. When a salt loses water to the air and turns to powdery form is efflorescent. The example is your sodium triosocarbonate for decahydrate. Okay, nursing impact. There is medication error risk. We must take note of efflorescent so that we can avoid medication error risk. Effervescent tablets like Alka-Seltzer will lose their potency if they are stored improperly. This will lead to ineffective heartburn solution. Okay. The next one is deliquescent. Deliquescent is when salt absorb water, they dissolve to form a solution. Example of such salts are your calcium chloride and sodium hydroxide. How does this impact nurses? IV line and clog. Sodium chloride, if left uncapped, can absorb humidity. They will form sludge and they may lead to embolism risk. Real case scenario. A nurse used deliquescent calcium chloride from a bottle left open. The particles clogged the IV line and led to pulmonary embolism. So we must take note of particles that can cause clogging so that they are not allowed into the bloodstream, else they will lead to embolism. Objective number 5. Objective 5 says metals and non-metals. Here, with regards to metals and non-metals, we don't want to look at all the metals in the periodic table or all the non-metals in the periodic table. We just want to take note of the ones that are relevant to nurses. So, metals versus non-metals, the nursing essentials. We look at properties and we look at their similarities, comparing both metals and non-metals. Let's look at the properties of non-metals and metals. They are both conductive. So with regards to conductivity, copper, for instance, is a metal and it is used in electrocardiogram wire. In electrocardiography, the wires are made of copper, and this is to ensure conductivity. For non-metals, oxygen are non-conductive. They are used for gas therapy, right? They are used for oxygen therapy. They are non-conductive. With regards to reactivity, sodium salt is used in IV normal saline because it is stable. For non-metals, chlorine is used as a disinfectant. It is very toxic if inhaled, so it's highly reactive non-metal. Metals also play biological role. Example is iron. Iron is used in treatment of anemia because it is present in hemoglobin. For non-metals, they also have biological role in the sense that carbon, which is present in carbon dioxide, is present in blood. That's why we can monitor for arterial blood gases. Nursing insight. Metals is equivalent to electrolyte in IV fluid, while non-metals are equivalent to gases which we use in respiration, such as oxygen and carbon dioxide. You monitor them in respiratory failure. Objective number 6, we want to discuss hydrolysis of salts. When we hear hydrolysis of salt, it means salt dissolving in water. It means salt reacting with water, leading to a change in their pH. Okay, hydrolysis of salt. Acidic salt. When acidic salts are hydrolyzed, they will reduce the pH. When basic salts are hydrolyzed, they will increase the pH. So let's look at it. Acidic salts such as ammonium chloride, when it is hydrolyzed, it will decrease the pH. For instance, as seen in this equation, ammonium reacts with water, leading to the formation of ammonia and the hydrozonium acid. So basically, what you should take note of is this, that anytime a hydrogen ion reacts with water, the hydrozonium ion is always formed. This is your normal definition of acid. Okay, anytime a hydrogen ion reacts with water, it will always give you a hydrozonium ion. Okay, that's H3O ion. Now look at this. This reaction will lower the pH. It is used in urine acidifiers for UTIs. This will prevent bacterial growth. Okay, acidic salts are used in urine acidifiers to treat urinary tract infections because they will prevent the growth of bacteria. Basic salt can also be hydrolyzed. So for basic salt, example of basic salt is your sodium acetate. So what happens is that acetate ion reacts with water. This will lead to the formation of acetic acid and the hydroxide ion. So basic salts, when they are hydrolyzed, will increase the pH. Sodium acetate is used to treat chemotherapy extravasation. What this implies is that during the administration of chemotherapy, if the IV line is not well in situ, what happens is that some of these chemotherapy meds can flow into vessels or areas they are not supposed to flow to. So what happens is that when it is noticed, sodium acetate is used to treat these extravasations. Objective 7. Want to discuss titration and volumetric analysis and their relevance to nursing. Titration. What is titration? The measuring of acid or base concentration by neutralizing them with a standard solution. What is volumetric analysis? Volumetric analysis is the use of precise volumes, burette, and pipette to calculate unknown concentrations. So basically, in the chemistry lab, a question will be set to you by your lecturers with regards to titration and volumetric analysis. We are going to see how this implies to nurses. There are various concepts in titration. They include endpoint, molarity, and neutralization. The first one we'll look at is endpoint. Endpoint simply talks about color change. How does this apply to nursing? It is applied in blood gas analyzers. Blood gas analyzers help to detect the pH of the blood via change in color. This will help us to diagnose acidosis or alkalosis. The next is molarity calculation. Molarity calculations is a concept of volumetric analysis that helps us in the bedside with regards to drug reconstitution. For instance, when 1 gram of vancomycin is diluted in 100 ml of normal saline or a solution or an infusion, there is need to calculate the milligrams per ml for safe IV infusion. The next concept is neutralization. Neutralization is a concept in volumetric analysis that is used for bedside nursing with regards to antidote for acid overdose. What happens is that sodium carbonate is titrated until the gastric pH is exactly 5.5. This will prevent mucosal damage, which is an erosion of the stomach mucosa. As I round off, the secrets to success which are vital for this course are as follows. This course is practical based, so take note in the practical sessions in the chemistry lab. Take note of efflorescence and deliquescence. Also take note of the differences of acid, base, and salts, as they are areas they usually set questions from this particular module 3. Some take homes. pH monitoring. Normal blood pH is 7.35 to 7.45. Take note, if it is less than this, it is acidosis. If it is higher than this, it is alkalosis. So pH that is less than 7.5 means that there is excess hydrogen ion present, and that is acidosis. pH that is greater than 7.45 means that hydrogen ion is deficit, and that is alkalosis. When you understand hydrolysis, you know why ammonium chloride treats urinary tract infections but will cause acidosis. When you master titration, you calculate antidotes in overdose. This isn't chemistry, it's the difference between a cold blue and a stable patient. Answer these questions in the comment section. A trauma patient developed lactic acidosis from hypoperfusion. Explain the chemistry behind their low pH and the rationale for fluid resuscitation. 2. A patient in cardiac arrest with a pH of 7.1 acidosis. Why do we give sodium carbonate? So these are hints that will enable you to answer the questions which I just asked, but I want to see your answer in the comment section. These are possible questions for your next examination. Define the following and give one example: acid, base, and salt. 2. List and explain 3 properties and 3 uses of acid, base, and salt as it is relevant to nursing practice. Differentiate between efflorescent and deliquescent substances. Give one example of each and explain their significance in drug storage. Discuss the concept of hydrolysis of salts, giving examples of acidic, basic, and neutral salts. Explain how this process is important in maintaining the body's acid-base balance. Explain briefly the principles of titration between an acid and a base, and describe how simple volumetric analysis can be used to determine the concentration of a solution in a hospital or laboratory setting. I want to thank you for staying this long on this video. If you have not subscribed to our YouTube channel, kindly subscribe if you find these videos helpful. Till we meet in the next module 4. It is goodbye.